I'm Dave Chalkness, and I'm going to talk today about ReCon, our system for revealing and controlling personally identifiable information leaks from mobile devices. This is joint work with my large team, led by my student Jinjing Ren at Northeastern University, and a number of other collaborators at several different institutions. One of the central questions that we address in this work is, what are your mobile devices sending out about you? Now, these devices, phones, tablets, we carry around with us in our pockets, in our purses. We love them because they're constantly connected to the internet. They have a whole bunch of interesting sensors that provide rich connectivity. They allow us to figure out where we are, how to get to where we're going, and a bunch of other information. For example, how many calories we're burning. But despite all of these wonderful things, we generally have no idea how this information might be shared with other parties. And so that's the focus of this work. The system that we've built, called ReCon, provides this visibility for users. So as I'm showing here, we have a web interface that allows users to see what information about them has been shared with other parties. It allows them to tell us if we're right or wrong, and allows them to tell us what we should do about it in the future. For example, should we block some of this information or should we modify it? So I'm not going to go into the details of exactly how ReCon works, and if you're interested in that, I encourage you to read our MobiSys 2016 paper and also see the talk that I gave at DTL last year. Instead, we're going to focus at a high level on what ReCon does and what we've been able to learn with it. So at a high level, what ReCon needs is access to the network traffic coming off a phone. There's a number of ways that we can acquire this. For example, we could use some of the tools that were awarded DTL grants this year, such as Haystack and AntMonitor. But in our case, what we do is a cross-platform technique to get access to network traffic without requiring any special permissions. And that is to use a VPN proxy. So we tunnel traffic to a server we control, and at that point we analyze traffic for privacy leaks. The way that we identify those leaks is using machine learning. So instead of asking users to tell us what their personal information is, we train classifiers that reliably predict when personal information is likely to be leaking in network traffic, then identify what that information is, and then provide that to users. Last, we use crowdsourcing. So we ask users to participate in the system and give us feedback as to whether our machine learning classifiers are doing a good job. If they are, and users tell us that they're correct, we can use this information to improve them, not just for those users, but for all users of our system. So at this point, I'm going to talk about some results that we've had based on our experience of using this system for over a year. So first of all, we have an IRB approved user study with over 300 users enrolled. About half of them were iOS, half Android. Notice that we have multiple devices per user in some cases. And we've done a number of analyses on this data. So from a small subset of those users, we were able to get detailed survey responses. And those users told us that they did find our system useful, and they changed their behavior in response to the information we shared about how their personal information was being exchanged with other parties. All told, we found 25,000 cases of personal information being leaked. Over 10,000 of them have been confirmed by our users. Within that set of personal information, we've seen 195 cases of users' credentials being leaked. Over 100 of those were verified. On average, we're seeing iOS users often see more leaks than Android users do, although we certainly can't generalize that to the overall population. And we've seen large numbers of unexpected and suspicious leaks from apps that you may use once in a while. Some of them you use every day, some you use multiple times per day. So this is just a sample of some of the apps where we've seen information being leaked. This kind of information can range from for example, very specific information about locations and unique tracking IDs, to other information, including your name and your address. So to make this information available in general, not just to individual users of our system, but to the public at large, we've created anonymized reports of what apps are leaking, and you can find it at the links that I've shown here. So we've also done the same for mobile web browsing, and on this page I've shown just a couple examples of what we found. So for example, the super bright LED flashlight, although its entire purpose is to light up a room, at least for users, that's its purpose. What we find is behind the scenes, they are sending unique tracking information to large numbers of other parties. And perhaps unsurprisingly, on the right-hand side, we see that Facebook is sharing a large variety of information with other parties. So, but besides finding information about users, we've also found sensitive security-related information from users being shared in inappropriate ways. And specifically, what we found so far is 22 apps exposing users' passwords in plain text over the internet. This was a bit shocking to us because some of these apps are used by millions. For example, Match and Epocrates are some examples of some of these apps that are sharing passwords in plain text. So to address this, we did responsibly disclose it to the developers. We gave them 3 months to remediate them. And more recently, what we found is that there's also cases of passwords being sent encrypted, but to third parties. And in one case, to a party that never should have gotten it in the first place. So in this case, Grubhub, we notified the developers who very quickly moved to fix the problem. But overall, we've gotten a variety of responses from developers. While most of them do thank us and they're grateful and move quickly and professionally, we've also found others that make claims, for example, that they are not a secure messaging app, so they don't need to use encryption, or that sending passwords in plain text is in fact intentional. For some developers, they weren't even able to fix the problem. And lastly, we've had cases where they just never respond. So I don't have time in this short talk to go into some of the more detailed explanations of the experiences we've had, but if you're interested, you can read my post on the DTL blog. Besides identifying security and privacy vulnerabilities and exposing them to users through our website, we've also worked on alternative ways of reaching out to individuals. One such effort is working with a filmmaker who followed his subject around for 1 week while we ran ReCon on her phone that was otherwise unmodified. Without giving too much away about the film, all I can say is what we found happening on this woman's device surprised even us, even after everything we've seen from the 300 users in our study. So this film, which is called Harvest, should start appearing in film festivals early next year, and hopefully by later in the year we will make it publicly available online. So stay tuned. Last, I want to talk a little bit about some of the tools that we've made available to improve users' privacy. So as I mentioned at the beginning of the talk, our ReCon system provides a dashboard where users can tell us what to do with information that's leaked about them. For example, they can tell us to block information, potentially replace it with something else to give them some level of anonymity. And they can also specify this per destination or to do things for all destinations, and whether it should focus on one type of medium in terms of sending information in the clear, in plain text, or over HTTPS. Besides the textual interfaces for showing users what information is leaking, we also provide a map view so that they can see what others learn about them. And more recently, we've developed an interface that allows users to compare whether the app or web-based version of an online service is better about protecting privacy. So to wrap up, ReCon provides transparency and control for user privacy. And we're very grateful to the Data Transparency Lab for their support. And for more information, please sign up at our website listed on the slide. Thank you.